Season 13, Forces in Motion, Episode... Can you please stop, Mother? Please stop. Give me stop. Mom, please stop. Anyways, it helps me learn. I like physics. I know. But I'm just trying to do this. I have this topic to do tomorrow. I'm not gonna fail anything else. Anyways, episode 91. Episode 91, Distortions. Welcome, strangers. You can squash a string, compression, so the forces pair to push it together. You can stretch a string, tension, so the forces pair to pull it apart. K is the spring constant, which is measured in newtons per meter. X is the extension, which is measured in meters. I'm not nonsense. It's not the same thing, Mom. It's a whole topic. I split it over 20 episodes. Every topic I've split over 20 episodes. Mom, the amount of planning that went into this, you cannot even imagine. The amount of thinking, the amount of oh, she's gone. Of course she's gone. Anyways, X is the extension, which is measured in meters. We can assume that the spring has not exceeded its elastic limit. The car comes from the word carriage, in which Robert Hooke used springs to suspend carriages to allow for smoother travel for the passengers, even on bumpy roads and uneven surfaces. We also assume that the spring is obeying Hooke's law, and it's not exceeded the elastic limit. There are quite a few assumptions being made here. Energy is equal to half of force multiplied by extension, so E is equal to half of Fx. Energy is also equal to half of Kx squared, so half of spring constant multiplied by extension squared. Energy is equal to half of Kx. No, half of Fx. Energy is equal to half of Fx? Energy equals half of force multiplied by spring extension. Yep. And energy is also equal to half of Kx squared. So half of spring constant multiplied by extension squared. See you next time at Physics in a Necrotic World. This is your host, Rimona Christian, R out.